Hello, my name is Raimond and my research was online forums immersed in paper, a study of exit passes. And what is an exit pass? So an exit pass is also known as an exit ticket, exit card or door pass, which is a small handout to be filled at the end of a lecture. And during my computer graphics lectures from 2015 to 2020, I handed out these exit passes where students had to answer two questions. The questions were, what did you learn today and what more do you want to know? Or some variations of these two questions. And here you can see on the picture stacks of paper exit passes from all of these different years. And now in 2020, unfortunately, we had all the lectures online. So I couldn't give out a piece of paper. And instead, we had a Google Forms with similar two questions. So what did you learn today and what more would you like to know? And we also asked the students their name. Now we can count these exit passes from previous years and we can find out how many filled them this year. So here are the counts of all these handed in exit passes. And there are also percentages of how much this count is of the number of graded students. So a graded student is a student who received a letter grade at the end of the course. And visually the data looks like this. We can see there is this distinct curve in the beginning and then numbers stabilize from around week 4. Now what we wanted to know was that if we had Google Forms, an online form that students had to fill out at the end of the lecture, or a handed piece of paper that students had to fill out, would there be or was there a difference in the number of students who filled those two forms out? For that, we did two tests. We did a Friedman test, which assumes that we have a matrix of data with no holes in it. And for that reason, we used the data from 2016, 17, 19, and 2020 because 18 was missing some data, and 15 was kind of these pilot courses which we thought wouldn't be that good to include. And the Friedman test shows us that yes, there is some significance here, that it's statistically would be correct to say that one of these series comes from a different distribution than the rest. And if we look at the pairwise comparisons, then it's clear that 2020 is the series that's different from the rest. For Kruskal-Wallis, we get a similar result. We use a bit different data because Kruskal-Wallis assumes we have a normal distribution, and it made more sense, or we got a better normal distribution if we just used the data from week 4 onwards and didn't include this first this drop here. And for Kruskal-Wallis, we also get a statistically significant result. And if you look at the pairwise comparisons, we find out two things. One is that 2020 is different from the rest, but we also see that 2018 is different from the rest. So it turned out that the 2020 time series was the worst, and 2018 was also different, and this was the best if we visually inspect the data. Now we don't have a good explanation on why 2018 was the best here, but this is what the test shows. But at least 2020 was different. Now you might be wondering, okay, we had the number of exit passes handed in. This clearly depends on the number of lecture attendances. So maybe it was the lecture attendances that we measured instead. And for that, we actually did the same two tests on the lecture attendance. Unfortunately, we don't have the exact lecture attendance from all these years. We only have it for 2020. But we can make a guess that, let's say 80% of the attended students handed in physical exit passes on previous years. And if we make that guess and do the Friedman test on now the exact data from 2020 and the guess data from 16, 17, and 19, then we see that there is no statistical difference in the data. When we do the Kruskal-Wallis test, we might have something going on here because the p-value is quite low. It's on this border where we could ignore it or not. But when we look more into the results and we look at the pairwise comparisons, we see that there's a lot of difference in 2018, which was the best data. So 2018 seems to be statistically different, and 2020 doesn't seem to be different here. So the attendance cannot explain the low exit pass attendance, exit pass handing in in 2020 via Google Forms in compared to the physical data. And thus the result is that the time series of students filling online exit passes is statistically different from the time series of handing in physical paper exit passes. And clearly said, it means that online forms are less likely to be filled than a piece of paper that's physically given. And the attendance p-values were high and the exit passes p-values were low. So while the attendance does play a role, it does not explain the difference in the exit passes in this data. And this was the research we did. Thank you for listening and goodbye.